All right, let's keep on keeping on. Let's do some other effective sampling methods here. We're out of section 1.4. So the first one that we're going to talk about is a stratified sample. All right, so a stratified sample is obtained by separating the population into non-overlapping, that's the key, non-overlapping groups called strata. Then obtaining a simple random sample from each, I moved it around, sorry about that, from each stratum, and the individuals within each stratum could be homogeneous or similar in some way. All right. The key to this one, there's a couple of things that I want to point out. First of all, it is non-overlapping, so you can't have the same thing, right? It's just one per deal. And then each one has to be similar as you're looking at into each stratum. So it's called a stratified sample because it's broken up into groups, and the groups are called strata. So remember how we've talked about mathematicians are not creative, so whatever it's called is what it is. So this one is called a stratified sample because it's broken into these groups called strata. All right, check it out. So obtaining a stratified sample is the owner of a private food store is concerned about employee morale. So she decides to survey the managers and hourly employees, two different homogeneous groups because they're similar in each way, right? To see if she can learn about work environment. From the list of workers at a store, obtain a sample of 2 managers and 4 employees to survey. So there are infinitely many. All right. So as you're looking through this, you want to say, how am I going to group this up? So this is stratum number 1. And stratum is just the singular to strata, the plural, right? So here's number 1, a homogeneous group based on managers. Number 2, a homogeneous group based on hourly employees, right? So similar groups based on these big 2 categories. So you just take 2 managers. There are lots in this list. Oops. Let me try again. I've got too excited about that S right there. Looks like lotus. Lots in this list. Pardon me. So that's what we're going for here. There are tons in this list. You could do anything. So let's just come up with some examples here. We're not going to list this whole thing. In your homework, it's multiple choice, and they're going to give you some choices, and you just say yes or no. So you could go with Carlisle and Oliver and these top 4. Archer, Fauci, Massey, and Bolsarek. Wow. That's really testing my skills, right? And then you could even go with Carlisle and Hills. You could go with Carlisle and Lindsay. I mean, any 2 out of this group and any 4 out of this group. So there are lots and lots and lots of possibilities there, right? The whole point of this is that you are broken into 2 groups that have something in common. That's what makes it a stratified sample. Not just 2, but groups. This one happens to be 2, but groups that have something in common, then you pull from each group. That's the whole point of stratified sample. All right. All right, let's try another one here. Systematic sample. So a systematic sample is obtained by selecting every kth individual. Selecting every kth individual from the population. So the first individual selected corresponds to a random number between 1 and k, and then every 5th person, that would be k, right? It's just some unknown. Every 7th person. It's just a system, right, that you're going through, and that's what makes it systematic sample. So here are the steps in order to pull this off. So if possible, get the population size, to determine how many you want in your sample, then divide it so you can see how many groups there are. And that's your value of k. If you can see how many groups that you have, then you randomly select a number out of that group, and then you call that p, and then that's the first number that you start with. Then you add the next group of k to it, next group of k, next group of k, until you finish up. All right, that's the system that you're looking at. So here's our example. So we are going to, so without a frame, remember a frame is based on the population. So I don't know how many there are at this particular Kroger food store. So it's just an unknown. So without a frame, because remember that's the full population is based on a frame. So the manager of Kroger food stores wants to measure the satisfaction of a store's customer. So we're going to design a sampling technique that can be used to obtain a sample of 40 customers. So that's my N, right? Because that's what a sample is your sample size of N. The manager randomly determined to start with customer number 5. So that's just where they're starting with this, is they're getting a customer number 5. This is without a frame. So we do not have capital N. So because we don't have that capital N here, because we don't have a frame, if possible, we do that. Well, we don't have that. We do have our sample size, but there's no way to do this part of it. It is randomly selected for my K. The manager did that for us and gave us our 5. Now we come up with where we're starting with this. All right. So my 5 here is the P value. So the first that I have in my deal here, that I'm starting at 5, is we're saying, well, one thing that we don't have, that we have, we're starting at 5, but we don't know our value of K because that wasn't given to us, right? So let's just say in the problem that's here, the manager chooses the 7th person, right? So every 7th person. So that's every 7th customer. I should write choose 7th. Like every 7th. 7 is the repeating that we're looking at. So then that means K is 7. So for our very first group here, we have number 5. And then in order to get the second value, I start with my number 5, but then I add 7 to that to get to the next person. So then I'm going to look at person 12. And then I add 7 to that again, right? So 5 plus, now I have 2 7s that we're looking at. And then that's how I get number 19, because I add 7 to that. If I add 7 again to 19, we get 26. Do you see how this is progressing? So I'm adding that 7 every single time, every single time, every single time. Now let's say I want to get up here to 40, because this is 5 plus 3 times that 7. ... I want to have the 40th customer, because that's my sample size of 40. So what number am I going to have for number 40 here? That's a 7. Okay, so check this out. And that's why it has this N minus 1. Because whenever I'm looking at these values, this is number 1. Let me make this a highlighter. This is number 1. This is number 2. This is customer number 3. This is customer number 4. But look at what's happening here. If I'm looking at this one, I have my very first one that we're starting with. Number 1 is the 5. That's my P. Then I add the K value to it. It's which number it is. I'm adding 1 K to it because I started with the P, so I only have 1 K for this second term. Then I have 2 Ks because this is number 1, and then I have these other 2 to make this number 3. Do you see what's happening here? So this is always 1 less than the number that I'm looking at because I started with the first one, and I only have to have this many groups of the next one coming at it. That's why this is P plus that N minus 1. So this is going to be 5 plus, because I want the 40th term, I've got 39 times 7. Because I've got 39 groups here, this is 39 of them, and then this would be my 40th person counting the first one. Does that make sense? Do you get what I'm setting at here? So then you get out your handy dandy calculator and you realize that this is customer number 278. So you've got customer number 5 to start you off with, then customer number 12, customer number 19 as you go through here, and then my sample size will end with customer number 278. And that will be my full 40 customers for my sample. And that's what makes it systematic. Every other one as we're going through. Now this is without a frame, but what if, oopsie daisy, I hit the wrong thing. What if I know that there are 4,368 customers? That is my N value. I still want a sample size of 40, so we're working through that. All right, so I take my N, which is 4,368, and I divide that by my number that's in my sample. 4,368 divided by that 40 will give me 109.2. And that's going to tell me my K value. So that's where we're up here at the K value. So K is just going to be 109. So then the next thing says randomly select a number between 1 and K so that you can call that number P. So we're just going to do that. I don't know. What are you thinking here? I'm thinking 20. 20 is what I'm going to go with there, because why not, right? So we're going to start with customer number 20 is kind of what's happening that. So any number is what we're choosing in order to get this. Any number from 1 to 109, and we're just choosing 20. There's nothing special about 20. There's no way for me to do that. You could put everything in a hat and pull one out. It doesn't matter. I'm just randomly choosing 20. And then you go through this exact same process. Pardon me. I'm starting with 20. Then, if I'm looking at this, I'm going to add 109 to that because that's my K value. So this is 20 plus 109, and it'll be, the next customer is customer number 129. Then, my next bit is I'll have 20 plus 2 groups of 109 that I have, and that will be 238. Do you see where we're going with this? So if I want the 40 customer, I'm going to be 20 plus, if I want customer number 40, yep, then I do 39 times the amount that's in my group, and that's, so plug that into your calculator, you get 4,271. So where people usually struggle on this is they're saying, what is this N minus 1? What are you talking about? Well, my first customer, and then it's one less to get to the next one because this is customer 40. So this is 1 plus 39 more groups, and that's how you get customer 40. Pretty cool, right?